Hello once again and welcome to chapter 17. In this chapter, I want to talk about how we can actually evaluate the performance of some code that we have written. And by this, I mean that we want to find out whether the code is performing optimally. Actually, the normal circumstance is that we might have two or more different ways of coding up a particular function, and we want to know which of these options will be the most efficient. So to do this, what we want to do is to measure the performance of a piece of code. Now at this point, I'm really only going to be talking about the time taken for a particular segment of your code to run. If you're interested in the memory usage of your code, well, we've already seen how to look at that, and we've also looked at the idea of performance of your application overall by using a profiler. So at this point, we're talking about a smaller segment of your code, not the entire application. In the last chapter, the profiler told us which method or methods are being called the most, or are being run for the most amount of time. So now it's time to look at how we might be able to improve those methods through the design and coding choices that we make as programmers. Actually, we are going to talk about some of those choices in the next few chapters, but first we need to know how to measure how long it takes for a piece of code to run. Now you might be thinking that this is a relatively straightforward idea, and we would know how to do that. We would simply record the start and the end time that it took for a particular method to run and calculate the difference. But unfortunately, it's not quite so straightforward as this because there are some complications. The first of these I actually introduced right at the start of the course. Remember, we learned that the Java virtual machine will decide which methods or code blocks to natively compile. Once a method has been natively compiled, it will run faster. So if we are testing two different versions of a way of coding something up, we might not know if one version's been natively compiled, the other one hasn't, and so this could impact our assessment of the performance when we're doing that comparison. Alternatively, we might do the testing with neither method natively compiled, but actually in production the methods would be natively compiled, and of course the performance could be different if it has been compiled compared to if it hasn't been. The second complication is that what might be the impact if a garbage collection takes place while our code is running? This could be a stop the world event, and that would change the time that we are measuring for our code to run, and yet it's nothing really to do with the actual code itself. Before we go any further, I want to introduce a jargon term. What we are doing here, measuring the performance of a small piece of code, is called a micro benchmark. Later in this chapter, we'll look at another type of benchmark, but what we're talking about right now, the micro benchmark, is about evaluating either a single method or a single code block. Having made that clear, I can now point out two further complications in measuring a micro benchmark, and that is that we'll be running the code we are interested in isolation. That is, we're not running it as part of the project in which this code sits. The reason why this can lead to inaccurate results is that the code might perform differently if it is being run in, say, a multi-threaded environment with competition for processors, memory resources, and so on. And the second, or should I say fourth complication, is that we're normally assessing the performance of some code on our development machine, and that's going to be different hardware. It won't match the hardware that the code will run on when it reaches the production environment. If our server has more processing power or more memory than our development machine, then the performance of the piece of code might well differ. In fact, many of the people who are considered authorities on Java performance, and many of the books written on the subject, say that you should almost never do micro benchmarking. There's not time within this course to really go into the detail of the arguments as to why, but practically it is something you may well want to do, and my personal view is that yes, you absolutely should be doing micro benchmarking, but don't make it your starting point in the process of performance optimization. What I mean by this is that you shouldn't start the evaluation process at the point when you're first writing your code. Instead, write the code, deploy it, and if it turns out that the method you're writing is being called once a day, well, it might be that optimizing the performance of that method is going to be a complete waste of time. If it turns out it's being called 100 times a second, then clearly that's going to be more critical. And it's the profiling process that we saw in the last chapter, the output from our profilers, that should guide us to consider which methods are worthy of consideration for optimization. When we've identified one of these methods and we know that there are alternatives for how to code these methods, that's when we should start considering the micro-benchmarking process. And in fact, that's why I've left this topic for so late in this course. For me, it's a natural follow-on to the profiling process. Now we know which parts of our application are consuming the most resources, we know which parts might be worthy of optimization, so we need a way to measure the different ways of writing these code implementations. Before we go further though, let me just stress that doing benchmarking by itself can be dangerous. What I mean by that is that it can tell us that we've got a more optimal piece of code, which actually, when it comes to it in the live environment, doesn't perform optimally at all. And in fact, at the risk of spoiling the rest of this chapter, that's what we're going to find when we use benchmarking to try and improve the way that a piece of code works. But maybe you'll forget I've said that and we'll carry on as we are and see what happens.